Good morning. This is Miss DH speaking, and we're going to do Chapter 12, Lesson 2 today, multiplying and dividing rational expressions. You guys should probably be very familiar with this because it's just the same as multiplying and dividing fractions. No joke, totally easy. It's just you gotta think about how things can be factored and whatnot. So it's going to be pretty easy. Hopefully you guys will get it. I'm not too worried. Okay, so let's go ahead and look at our first example. Well, really, multiplying rational expressions is similar to multiplying fractions. So let's take a look at that. So if we have a over b times c over d, to multiply fractions, we just do a times c and b times d to give us ac over bd. It's the same thing if I were to replace these with numbers. 1 over 2 times 3 over 4 is equal to 1 times 3 over 2 times 4, which is the same as 3 over 8. All right, so it's basically what we're doing, but with things that have exponents and adding and subtracting. You know the drill. So let's look at our first real example. 6 over a to the second times negative 2 over a to the third. Well, we're going to do it just like we do with regular multiplying fractions. It's going to be 6 times negative 2 over a to the second times times a to the third. Well, simplify the top, simplify the bottom, and then divide if possible. So it'd be negative 12 over a to the fifth. And that's it. You can't simplify it. That's your final answer. All right. So then number 2 is x minus 5 over x plus 3 times x minus 7 over x. Well, the tops get multiplied together. The bottoms get multiplied together, and that's as simplified as it gets. Okay, there's nothing that can cancel out. There's nothing you can divide. There's nothing you can factor. This is actually the simplest answer for this one. But don't worry, it gets harder. So let's go ahead and look at the next slide. Yes, that's the simplest form. Go figure. All right, so look at the common factors to divide out because sometimes a times c over bd is not in simplest form. So this is where it gets a little more difficult. So number 1, we have x minus 2 over 8x times negative 8x minus 16 over x squared minus 4. So time to factor some stuff out. But let's first rewrite this so that everything's getting multiplied. There we go, just rewriting it. And now let's start factoring some stuff out right there. So I can pull a 8 or a negative 8 out of negative 8x minus 16 right there. And I can factor x squared minus 4 because it's a special case and it's a difference of squares, so therefore I can get to those things. Now I'm going to rewrite the problem with everything I've got, and now notice how I wrote negative 8 as negative 1 times 8, and that's going to allow me to cancel out these 8s, and it's going to allow me to cancel out, again, whatever I have the same on the top and the bottom, I can cancel out. So that x minus 2 and the x minus 2 on the bottom will cancel out. That x plus 2 and the x plus 2 on the bottom, top and bottom, cancel out, leaving me just negative 1 over x. Isn't it amazing how simplified math can get? That's why I personally love it. And I hope you will personally love it as well. It's because you can turn some nasty problem like that stuff at the beginning into something so elegant like negative 1 over x. Anyway, let's move on. So keep a lookout for special cases and remember to factor whenever possible. There you go. All right, so let's multiply a rational expression by a rational expression. So we have 3 over c times 3 to the third, or c to the third minus c. So let's go ahead and rewrite this. And again, whenever I have just a number, I can write it as a fraction by putting it over 1. So then we're just multiplying fractions. So let's go ahead and multiply. The thing is though I can pull a c out of the c to the third minus c, and it gives me this. Factor out a c. But the only thing is that c to the second minus 1 is a special case. So I can factor it even further, and it's a difference of factors. So really all I can cancel out is the c, but it's not in simplest form unless I factored that c squared minus 1. Okay, so that's why your final answer is 3 times c to the first times c minus, or excuse me, 3 times c plus 1 times c minus 1. So again, you need to make sure you factor everything you possibly can, all right, because it's not in simplest form until you factored everything. All right, next example, number 2. 2v over v plus 3 times the quantity v squared minus 2v minus 15. So that's a quadratic expression there, right? Quadratic expression, which means we can factor it using our table. So let's go ahead and multiply first, and then let's go ahead and factor. So there we go. So definitely, just like the last video, you need to make sure that you factor completely, and then you're ready to cancel out wherever possible. So again, if you have the exact same thing on the top and the bottom, you can cancel it out. In this case, it would be v plus 3 is on both the top and the bottom, which means they cancel out, leaving you a final answer of 2v times v minus 5. There we go. All right, third example for this particular slide would be m minus 1 times 4m plus 8 over m squared minus 1. Don't forget to factor completely. Well, I can pull a 4 out of 4m plus 8, and I can factor m squared minus 1 because it's a special case. So let's pull those things out. And then let's pull that special case, factor that special case, and now we can cancel out whatever we can. In that case, it's just those two things. So that's leaving me with 4 times m plus 2 over m plus 1. All right, let's move on. So, dividing rational expressions, just remember, it's like dividing fractions. A over b divided by b over c is the same as multiplying by the reciprocal. I hope you guys are having total flashbacks from 6th grade and 7th grade when you say, how do you divide fractions? Well, you multiply by the reciprocal. So we're going to end up with a times b over b times c, or excuse me, a times d over b times c. All right, so we're going to use the very same concept to do this with rational expressions. So first example, a minus 2 over ab divided by a minus 2 over a. So we're going to multiply by the reciprocal, and remember we always take the reciprocal of the second fraction. So there's the reciprocal. Then we're going to multiply, which is a times a minus 2 over ab times a minus 2. Cancel out what you have in the same as the top and the bottom, which would be your a's and your a minus 2's, leaving you with just 1 over b. That's simple, folks. Yes, I swear, it's that simple. All right, next example. 5m plus 10 over 2m minus 20 divided by 7m plus 14 over 14m minus 20. This is getting a little bit more difficult. So let's go ahead and multiply by the reciprocal to see what we have to start with. And again, we're doing the reciprocal of the second fraction. So there's the second fraction, and there's the reciprocal of it. So you guys can check my work. Now, we've got a lot of things we can factor here. We can pull in a 5 out of 5m plus 10. We can pull a 2 out of 14m minus 20. We can pull a 2 out of 2m minus 20. And we can pull a 7 out of 7m plus 14. So let's do it. Pulled out the 5, pulled out the 2, pulled out another 2, pulled out a 7, cancel out what you have the same on the top and the bottom. We have some 2's that can cancel out and some m plus 2's that can cancel out, leaving me with just 5 times the quantity 7m minus 10 over 7 times the quantity m minus 10. So, and again, you can't cancel these out because they're in different places. So again, not exactly the same on the top and the bottom, which means you can't cancel them out. All right, third example. Oh, some factoring. Oh, lordy. Well, I'm going to go ahead and multiply by the reciprocal. And then I'm going to factor the top, which is the 6n to the second, minus 5n minus 6. So I'm going to go ahead and factor that. And you can check my factoring if you don't believe me. And then I'm going to factor the bottom part, which is the 2n squared minus n minus 3. There we go. Factored away. And now I can start canceling things out. So, sorry, Mr. Michaels walked in and I had to pause for a second. So, but this is good though because we've already factored everything and now we can start canceling everything out. And check that out. 4 of the 6 things cancels out, which leaves us with our final answer. So, let's move on to the next and last slide. So, dividing rational expressions by a polynomial, just remember that you can turn any polynomial into a fraction by placing it over 1, so that when you need to divide by the reciprocal, you're just doing it with 1. So there we go. There we go. See, there's that 1. The reciprocal of negative 15x to the 5th is 1 over negative 15x to the 5th. Now we're ready to multiply like we've been doing so far for the previous last 4 slides. And then, hey, we can just cancel some stuff out. And just notice how I wrote negative 15 as 3 times negative 5, and that's because I want to cancel out the 3's. So I'm going to cancel out the 3. 3's, I'm going to cancel out 3 x's, and I'm left with my final answer, which is 1 over negative 10, because it's 2 times negative 5, so negative 10 times x to the 2nd, because there's 2 x's left. Pretty easy, right? Pretty easy, cheesy, lemon squeezy. All right, next to last example, we have y plus 3 over y plus 2 divided by y plus 2. Remember that you can put y plus 2 over 1, then do the reciprocal and multiply, and that gives you that answer. And just note how I wrote y plus 2 times y plus 2 as y plus 2 to the 2nd power. Pay attention to that, because that is how you would write it in simplest form. And my last example does involve some factoring, so let's go ahead and get to it. I'm going to multiply by the reciprocal, which is going to give me that, and now I'm going to factor z to the 2nd plus 2z minus 15 is going to give me a factored outcome of z plus 5 times z minus 3, and I'm going to factor the bottom, which is the z squared plus 9z plus 20, which gives me z plus 5 times z plus 4 times z minus 3, cancel out what we have the same on the top and the bottom, and we're left with just 1 over z plus 4. Again, guys, this crazy, crazy stuff can give you a simplified answer of that. Isn't that amazing? Okay, I believe I am done. Have a good day, and we're going to have fun with this. All right, bye.